Let's take a look at a few more examples of finding all the zeros of a polynomial. So the goal is that you're going to reduce the polynomial that's larger than a quadratic polynomial to one that is quadratic. So therefore you could use some quadratic techniques to find the rest of the zeros. So in this first example, we're given x plus 3 is a factor of the polynomial. So therefore we know that negative 3 would be the root. How many zeros or roots are there goes with the degree of the polynomial. So in this case, the degree was 3. So there are going to be 3 roots. It always goes directly with the highest exponent of the polynomial, which is your degree. Then we're going to use the root to reduce the polynomial using synthetic division. So using our root, which was negative 3, we're going to put that in the little box to set up for synthetic division. And then we're going to write down our coefficients. So we have 1, 1, negative 7, and negative 3 are the coefficients of the polynomial we're trying to make smaller. Bring down the first number, so we bring down the 1, and then we start the pattern of synthetic. So 1 times negative 3 is negative 3. 1 plus negative 3 is negative 2. Negative 2 times negative 3 is 6. Negative 7 plus 6 is negative 1. Negative 1 times negative 3 is positive 3. And then we should end up with 0 because we know this should come out evenly. And so what we have left is a quadratic equation. We have x squared minus 2x minus 1. So we're going to pick out a, b, and c. So a is the one in front of the quadratic term. B is negative 2, and c is negative 1. We're going to set up the quadratic formula and plug those in. So the quadratic formula, let's recall, is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And then we're going to plug in our a, b, and c values. So x would equal negative b, which would be positive 2 in this case, because it was a negative 2, plus or minus the square root of b squared, so that would be negative 2 squared, minus 4 times 1 times negative 1, all divided by 2a, so that's 2 times 1. And then we just have to reduce that to be the simplified form of it. So let's type or think about the number underneath the square root and what that would equal. So we have x equals 2 plus or minus the square root of, and that would be 4 plus 4, which would give us 8 underneath there. But that helps you get most of the way there, and then you have to focus on the square root of 8, because a lot of times you could reduce that a little further. So the square root of 8, we could break up into 2 times 4. 4 comes from 2 times 2. And then we could take out a 2 and have 1 left over. So the square root of 8 becomes 2 square root of 2. And then you just have to come back over here and put that back into the problem where you left off. So you have 2 plus or minus, and then in this place where the square root of 8 was, we're going to put what it's equal to in a simplified form. So 2 square root of 2. Then it's all still divided by 2. And now we're almost finished. We just have these 2's out front. So those 3 2's in the front of the radical could be reduced because they can all be divided by the same thing, which is 2. So you get x equals 1 plus or minus the square root of 2. So now that you have found all of your roots, it's good to write them all together. We needed 3 zeros because this was a cubic function. So all of our roots together would be x equals the first one they gave us, which was the factor x plus 3. So our root was negative 3. And then we just found 2 more. We have 1 plus the square root of 2, and we have 1 minus the square root of 2. So that's all 3 roots for our polynomial have now been found. So let's look at another example. This one does not give you a root to start with, so I've typed it in the calculator over here to the right already, and I'm going to go to the table to look for an x-intercept. So I'm going to hit second graph to check the table. Let's see. There we go. So let me change the window back to normal. let's see, second graph. All right, so you want to find where y equals 0, because that is your x-intercept. And so the x-intercept in this case would be at -1. So x equals -1 is my x-intercept, and that is a root. And so that would help us to get started. So put that in the box and then write out your coefficients. So I have 1, -1. I need a 0 because the x is missing in my original polynomial. And then I just need to bring down the 2. Then drop down the first number, so that's the 1. 1 times -1 is -1. Add those together and you get -2. -2 times -1 is +2. Add those two together, the 0 and the 2, and you get 2. 2 times -1 is -2, and we end up with 0, which we should because we should not have a remainder at that point. Then you have x squared minus 2x plus 2 left over. So let's go ahead and pick out A, B, and C. So A is equal to 1, B is equal to -2, and C is equal to +2. And then let's just write out the quadratic formula again so you can see it one more time. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to plug in the a, b, and c values that we picked out. So we have x equals -b, which would be +2 now, plus or minus the square root of b squared, so -2 squared, minus 4 times a, which was 1, times c, which was 2, and then all divided by 2a, which is 1. And like I mentioned before, the cleanup of this part is where we really just need to be careful to not make an error. All right, so we get x equals 2 plus or minus the square root, and that would be 4 minus 8, which is -4. And so -4 under the radical, or the square root of -4, the negative would come out as the I that you learned about in Math 2, and then you still have the square root of 4. So we need to take plus or minus and make it 2i is how we can simplify it. But then we got to put it back into the problem. So let's come back over here and put it all together again. So x equals 2 plus or minus 2i all over 2. And then we could just reduce all of the 2's because all 3 of them could be reduced by dividing by 2 and write x equals 1 plus or minus I. And so now let's put all 3 roots together. We know we have 3 roots because it was a cubic function. There are 3 roots. We found one quickly in our calculator at the beginning of the problem. That was -1. And then the other 2 we just found using the quadratic formula. So we have x equals 1 plus I and x equals 1 minus I. Okay, so that's just some more examples to help you get started.